So I'm Scott Stanchfield, and my website is, wow, I'm just scribbling all over the place really poorly today, huh? javadude.com. I have a bunch of other videos of other talks that I've done for the Columbia, Maryland Jug and for other places. Feel free to take a peek at some of those. I'll be posting a video of this after the talk tonight, so I'll put an announcement on the CM Jug list. Did everybody find this through the CM Jug list, or how did you find out? Any other ways? Just through the CM Jug list? Good. Make sure you tell your friends. It's like we like lots of turnout, and we've got a good sized room here. Everybody comfortable where they are? Okay, so let's talk about lambdas. Now, one thing I want to say right up front, lambdas are not closures. So if you use closures in other languages, it's not the same thing. All a lambda is in Java is a really nice, concise way to write an anonymous inner class. And this is where everybody goes, "Aww." But it's actually very nice little syntactic sugar for it. Really saves a lot of writing, and I think it's a lot more readable. The big difference between a lambda and a closure is a closure captures the execution context at the point it was defined. And so if that context changes, the closure will see those changes. So if you define some local variables, for example, then you define your closure. The local variables can be seen by that closure, excuse me, and you can act upon them. So you could change them, you could read their current values. With an anonymous inner class or a lambda in Java, any variables you have set before the lambda is defined basically have to be locked down. And the reason for that is the way that they implement anonymous inner classes behind the scenes. They copy values in. They don't keep pointers to the execution context in which they were defined. So things are effectively final when you jump into your lambda. So that's kind of the biggest difference between a closure and a lambda. Is closure is a little bit more dynamic. Okay, how many people here have done anonymous inner classes before? How many people are comfortable with anonymous inner classes? And the hands go down, yes. This is something that in Java, you don't have to use them. And I suspect that lambdas will actually make it much more appealing to use something like an anonymous inner class. But anonymous inner classes are really, really ugly. I'm going to go through a couple examples using them to start with, and then move into lambdas from there, just so you can see how they actually work. So first thing I want to talk about is the idea of the observer pattern. An observer takes an observable object, which is something that you care about, something that you want to find out when something happens. How's that for nice and vague? And you have an observer, which will be notified when that something interesting happens. Now to make it a little more concrete, maybe this guy here is a button. When the button is pressed, I want to know it was pressed. So I can attach an observer to it and be notified when the button's been pressed. We do that by calling an add method to add it, or a remove method to remove it. And then whenever the observer wants to actually notify people, it just walks through the list of everybody that was added. Okay, pretty simple interaction there, but it's very nice and effective because it separates out this guy from this guy over here. Now, observer is a form of the strategy pattern. Strategy pattern is really generic. It basically says, hey, I've got an object here, and he's going to do some stuff. Maybe part of that stuff I want to vary. So I can plug in another object to provide that behavior. Observer is basically that type of thing. You're plugging in the observers to add to the behavior when something interesting happens. So we're going to look at these two patterns in a couple examples, and then whittle them down to use lambdas instead of inner classes, just to make things a little bit neater. So we're going to start off. Let's create a new class here. I'll call it lambdas. And let's create a little user interface that when you press a button, it just reports on the screen, hey, I've been pressed. So I'll have a public void go. And yes, my fingers are getting used to the keyboard again here. And inside here, I'm just going to say new JFrame. And come on, buttons, work for me. And then inside here, I'm going to say set default close operation. exit on close, and we'll do a pack before that, and then we'll say set visible, and then let's just set up a little button inside here. So I'm going to say add new button. And the button is going to say add action listener. This is where we hook in our observer. Whoops, I didn't want an unlistener class yet. I need to give it some object that it's going to communicate to tell it the button's been pressed. So let's just start off by using the Lambdas object as our action listener. And this is what a lot of people, early on when you'd use buttons, people would define things this way. So I'm going to say lambdas.this. And then we're going to define a method here, action performed. This is the implementation of that action listener. This is the method gets called when the button's pressed. And so we'll just say lambdas button pressed. So when this button is pressed, hopefully we'll actually see that little message come up there. Now I need a main to actually run this. And we'll say new lambdas, go. And let's try running this guy. Oops, let's put a name on that button. And we'll run him again. Now when I press the press me button, boom, button pressed. Ta-da, how exciting, right? Now, what's wrong with this? Why is this a bad idea to have the observer be that lambdas class? Any thoughts? Okay, how doesn't it scale well? Mm-hmm. Okay, so one problem here is that this defines one true action, right? So we're defining it as the lambdas has only one action that can be performed. So if I added this to several buttons, I'd have to deconflict inside my action performed by saying which button was pressed, right? So that's one thing that doesn't scale well. That's a good point there. Not what I was looking for, but that's actually a very good point. What else? Why else is this a bad thing? What's that? It's very tightly coupled between lambdas and what's going on inside. Now, I don't mind that so much here because this is actually defining that button. So having him define what to do with his button, I don't mind quite so much there. What about visibility outside of the lambdas class? The way I've defined this now, anyone could take this lambdas thing and add it to any button they want to. So I've actually exposed something that I meant to only apply to my button to the outside world. So somebody could create a new instance of the lambdas class and attach it to their button and then call my action performed. Really not the behavior I wanted, and it might not work properly depending on how they actually use my class. So I really don't like having that observer interface listed on the outer class like that. So I'm going to leave him there just so that you can see this example later on. But what I'd prefer to do is pull that out into its own separate class. Now I can do that by creating a new class out here, press me listener, and we'll make it an action listener. And then we'll come in here. Let me just copy this like that. And I'm going to say, well, let's just call it external. So then the external listener is pressed, external listener is triggered, we'll call that. So this time, instead of adding lambdas this, I'm going to add an instance of that external class. Just like that. So now if I call this guy, press me, boom, external button's pressed. Make sense so far? Okay. Now, the problem with this is that this action here is probably only useful inside my application. It's probably not something that's generally useful in any application somebody wants. And it may not even be useful past one single button, because I probably have some very specific actions in here and what to do when that specific button is pressed. So having it as an external class probably isn't really useful to anybody. It ends up cluttering up my namespace a little bit. So when I take a look out here in my package, I now see two things. And if you think about this, if you had 20 buttons, you'd see 21 classes in there, only one of which is really what you care about. The other ones are all just saying when the button's pressed, do something. So that's when people started moving these classes inside. So we can take this guy and come over to Lambdas and define an inner class up here. Oops. And we'll say internal listener. And I'll say internal. And notice all I did was copy the class definition inside there. Now, depending on how I want this used, I might want to make it private so that people on the outside can't get a hold of it. So now I'm restricting it to just being used inside this class. So I can come in here and say new internal listener, just like that. And so now if I run this guy, press the button, the internal one's called. Okay. So now this has scoped it down a little bit more so people can't get a hold of things. Well, you still have a little bit of namespace pollution here. I had to come up with this new name, internal listener, to define what to do for this button. And I'm only ever using it in one spot, so does it really need a name other than being able to reference it in that one spot? So this is where they came up with the idea of an anonymous inner class, which is a really crazy, incredibly ugly structure. But it basically says, you know, I really don't care about what I call this, I just want to do it. So I come in here and I say new action listener, paren paren. And what that means is that I want to create an instance of some class, I don't care what his name is, that implements this interface. And here are the details. So you're just defining it in line, you're skipping the whole need for having any type of name on it, and boom, there he is. So I'm going to take the code here and move this down inside there. I'm going to say anonymous. Okay, that's some crazy ugly code there. And I went ahead and made it even crazy uglier, right? I bet when people saw me put those lines together, they all went, ew, right? Anybody cringe when I did that? Why did I do that? Any ideas? It stops you. It makes you think something weird's happening here. And in this case, it shows when the anonymous inner class ends. So it's a really nice way to stop you at that spot so you can very visually see, boom, end of this anonymous inner class. Now, I only like to do that when there's a single method in there. Otherwise, it looks a little bit funky. But this really helps break it out so that your eyes can follow it a little bit more easily. At least that's what I found. So that's just my own ugly style that I like to use there. Let's run that, make sure it works. Press me, boom, anonymous pressed. Okay, now take a look at this thing. We have this object created just to have a single method, just to call this single line of code here. This is what we care about, right? We don't care about having a class. We don't care about having a method. We just care about doing that action. This is where lambdas come in. We can reduce this to just focusing on that line. I mean, all this extra gobbledygook around here distracts you from seeing what the real thing you want to do is. Let me just make sure that my recording is still going here and make sure I'm not muted. I made that mistake when I was teaching a class the other night. I had my mute button turned on, which doesn't really help anybody. Good, recording. I like to check that once in a while because I get a little paranoid about that. Okay, so what we're going to do is let's comment this guy out up here. And let's change this into a lambda. So I'm going to start with the most verbose lambda syntax. And then we'll work our way back from there. There we go. That's much nicer, isn't it? Let me write in here lambda 1. So what we're saying here is I've got one parameter coming in. That's going to be that event listener, or the event object here, this action event. And that's going to be a parameter that can be used in this chunk of code over here. So I'm just going to say system.out.println, print this thing. Here's my parameter, do this. That's much more readable now, isn't it? We got rid of extra gobbledygook. Let's just make sure that works. Kaboom, button pressed. Pretty simple, huh? Now what this is doing is this is actually generating this for us. It creates this little inner class that it uses to adapt to be able to implement this. And what he says, okay, action listener coming in. What parameter do I need? I need an action listener. Well, what does action listener have? Oh, he has a single method, and that's the key, a single abstract method that has an argument of type action event. Boom. So he knows that E must be an action event. He infers that. And then that single method will be called, passing that method, and here's the body of that single method. And so it just generates that for you. So it's a real nice time-saving thing and visibility-saving thing and understandability aid. Make some sense so far? So it's a real nice short syntax. Now this only works in Java 8. It won't work in previous versions of Java. And there are some runtime library support issues behind the scenes where you can't just compile using Java 8 and run in Java 7 or earlier. So don't try to do that. There is a tool out there that tries to let you do that, but it's a really, really dangerous tool. Because when you compile against Java 8, you're hitting methods in the Java 8 runtime libraries. And those methods may have different signatures, or the methods may not even exist in Java 7. And what will happen is your bytecode will contain those references to those methods, and you'll never know there's a problem until runtime. So unless you test every possible path in your code, there's no way to know that your method signatures are going to resolve properly. That's something the compiler is very good at. And so if you compile against the version you're running at, or against a later version, or compile against an earlier version to run in a later version, you have those checks that the compiler does for you, and that's a great thing. But compiling with a newer version and trying to run in an older version, really bad idea. And that tool that's out there actually kind of psychs out things a little bit by changing the was compiled by version number in the bytecode. Really, really bad idea. So I don't recommend you do that. Okay. If you are interested in trying to use lambdas in previous versions of Java, I'm going to show you another tool after this. It's called Extend, and it lets you generate Java code using lambdas, using other fun stuff. And it has some dynamic dispatch capabilities. It's a really nice tool. Okay, so now we've got this little lambda here. Let's simplify it a little bit. The parameters to that method go inside parens here. If there's only one parameter, you don't need the parens. If you have more than one parameter, you have to have the parens. So I'm going to get rid of the parens there. Boom. And then I can run it again. Let's call this lambda 2. And there we go, lambda 2 button press. So far, so good. Now, if you only have a single expression here, you don't need the curly braces around it. So we can reduce that. Something kind of like that. We'll call this lambda 3. It should be a single statement or single expression. So in this case, and it also depends on if you need anything returned from it. So it could just be an expression that returns something. So it doesn't have to be a statement. I'll press it, and lambda 3 is pressed. So it's reduced that now down to some even simpler code. Now, unfortunately, there's no shortcut that says, hey, I don't care about the parameter. I would have liked that if they would have had that, so you could actually take this one step further and say, if you don't care about the parameter, just do that. You know, unfortunately, that part doesn't work. Okay, so far so good. Question? Or? I'm sorry, I couldn't hear that.
So what does the compiler do to the public expression?
It's, first of all, the whole construct here with paren, something paren, and then the arrow. The arrow is the main key there that's telling it it's a lambda, but it's also looking for the paren with the expressions there. If it doesn't find them, then it only depends on that arrow and assumes there has to be a single one. It really has to look forward past the parens because this could just be a parenthesized expression. that you're passing as an argument? There we go. Did that answer you okay, or? Okay. Other questions before I move on? Mm-hmm. Mm-hmm. So the question was, a lot of the languages have a proper lambda type, and Java doesn't really have that. We'll see in a little bit exactly what's going on. You can define a function, which is basically a function object, and assign a lambda to it. So it's basically creating just a function object. Really, all this is doing is taking this and creating an instance of an anonymous inner class for you. So it's actually just still an object with a single method in it. Okay. So now let's say that what we cared to do here was to print out that object, that E. So if I just wanted to say system out println E, or do something directly on that variable, and that's the only thing I'm working with is E itself, like that. Let's see what this looks like first. So we'll see it's kind of an ugly two-string type print there. But if that's all I wanted to do, notice how the argument is being passed to that method completely unchanged. So I'm not tweaking it, I'm not grabbing any data from it, I'm just passing it directly. If that's the case, you can do one more shorthand. We can do something called a method constant. That looks like that. And what this says is I want to run system out, that's an object. I want to run his println method against whatever's passed into me. Does that make sense? So if I run this, boom. And you can do that with either instance methods by passing in the instance and then the method name, or a class name and then a method name if you want to run a static method. Make sense? Okay, and those are fairly useful. We'll see a little bit later when we're doing streams that they can actually really shorten up things quite a bit when you're writing your expressions there. Okay, and that's called a method constant. Now, if we had multiple parameters, let's try a little example that has multiple parameters. A good one is if you're trying to sort a list using a comparable. Let's create a new class here. And so in here, I'm going to say, give me a list. Actually, let's make some people here first. Okay, so here's a nice simple person that has a name and an age. And so in my sorting here, I'll say list names equals new. Well, let's make him of person. And then I can say people.add new person Scott. Oops, what does he not like there? Did I go the opposite direction? Name. Oh, I made it string. Oh! That should fix that now. And there we go. Throw some people in the list. And if we want to print this list out, you know, we'd normally just say, whoops. Let's throw a toString on that person as well. Let's go ahead and run that guy. Okay, so everybody's being printed out just fine. Now let's try sorting this. Now, if I were to, whoops. if I were to use collections.sort on this guy, I can pass in people, and I can pass in a comparator, kind of like this. And I'll start off with an anonymous inner class for this guy. And I'm just going to compare these. I'm going to say, let's say we want to sort by the names. So we can do something kind of like that. And we run it, we should get everybody sorted. Okay, so far so good. Now notice that there are two parameters to this guy now. So I can't use a method constant here. I'd have to use a parenthesized parameter list in my lambda. So let's try converting this to a lambda. So I'm going to go down here to where the parameters are. Boom. And do that. That's a little more readable now, isn't it? We're just compressing it down to just the stuff that we care about. Let me get rid of that guy there. And we'll run him. And we'll see that we got everybody sorted by name. Now, if I wanted to sort by age, I could do something like that. And boom, now I've sorted them all in order of age. Okay, so this makes comparatives a little bit easier to write. You don't have to worry about all that extra gobbledygook for the anonymous inner class. Make sense? Okay, so let's see, I got those in there. So let's say you want to define your own lambdas. You want to define something that takes a lambda and processes with it. Well, all you have to do is create an interface for it. Now what I'm going to start with is, let's copy a little binary tree node up here. So I create a little class here. Is the font size okay up there for everybody? I should have asked that. Okay, anybody squinting, because I don't want anybody's eyes to hurt. I'll just make you move to the front. Okay, so what this is going to be a binary tree that can take any type of data that's comparable. So as long as it implements comparable, which allows you to say, when I compare with something else, am I before or after him? I can put it inside this tree. So I got a nice little add method that just says add me on the left or add me on the right, depending on if I'm greater than or less than. I got a little method to get the data, method to get left and get right, and then I got a method down here to perform an in-order traversal. Print the stuff on my left, print me, print the stuff on the right. Now what I've done here is create a little process method to actually do the real data handling here. So that handle stuff on the left, and then it's going to print me out, and that way I could just change this method to be able to change what action actually happens. So let's create a little trees class. And in there, I will say binary tree node person root equals new binary tree node new person. Oops. Scott, something like that. Okay, I need to change person to be comparable. Something like that. Okay, now what's the disadvantage here to using comparable versus comparator? You can't change the sorting order. We've now defined the one true way to sort inside this object. Not generally a good idea. Now it's okay to have this as kind of a default sort order, but then comparator lets you change the sort order on the fly. So if we really wanted to make this binary tree node a little nicer, we could pass a comparator in as well, so we could determine what the sort order is. But we'll just rely on comparable for this. And so now I'm going to say root.add. Let's just copy that from my sorting example. We'll just try printing that out. Let's just see how this ends up working. And there we go. So now we printed them out in alphabetical order. So they've been sorted in the tree in the right order there. So far, so good. Now, let's say that we want to make this binary tree node a little more flexible. Right now, he just has one thing that he will do to process nodes in that tree when you're doing the in-order traversal, right? So the first thing we could do is take advantage of the gang of 4 template method pattern and create subclasses of this that simply override the process method. There's a couple little gotchas there. One, this guy's private, right? So I need to make it protected so the subclass can override it. And maybe I just want to say, you know, top level class, let's make it abstract. So somebody has to override it in order to provide overridden functionality. So let me make a copy of this guy. And so I'm going to make this overall guy abstract. I'm going to make my process method protected and abstract. Now I got to deal with creation of subnodes, because when something's added, I'm creating those subnodes automatically. I want to make sure I'm creating subnodes of the appropriate type. So I'm going to create another method that you can override that allows you to create these nodes. And basically what I'm doing is creating a factory method here and letting the factory method be overridden in the template method subclass. So I'm going to take this guy. Oops, wrong one. And we'll say create. There we go. So now we got this nice little factory method. I'm going to make him protected abstract. Kind of like that. And then we'll create a subclass of this guy. And we'll define these two things here, like create a new print node. Let's make him have a why is he complaining? Constructor, that's what I wanted. Passing in the data. And why does he not like that? Oh. There we go. And then for process, we can take that little print that we had and put it in there. There we go. And we'll say println get data. Okay, so now back to our trees here. I can now take this and change this to print node. There we go, and let's run that again. And so now we see they're being printed out, but we're using this new structure. Okay, so now we have that template method. Now this helps us a little bit because now we can change that action. But it'd be much nicer if instead of having to create a new subclass every time you want to do something, to just pass in that action that you want to perform. So what we can do is create a binary tree node 3. And let's see. Actually, I'm going to copy that from the first one. Hey. And I'm going to let the thing do his own creation. I don't want people to subclass this. I'm just going to mark it final just to make sure I don't accidentally subclass it. And what I want to do is take this process method and let it be passed in. Now, in order to do that, I need to define an interface that represents what I'm passing in. So I'm going to create a little interface here called node handler. Now note I'm doing this exactly the same as I do any other interface, except because I now have Lambda support in Java 8, I could pass a Lambda in instead of an actual anonymous inner class. So my node handler is going to have a void handle binary tree node. Oh, it's 3 I wanted. Binary tree node 3. And he's going to just have a T in there. Kind of like that. So there's my node handler. And then in my binary tree node 3, I'm going to pass him in oops, actually I just want to pass in the data. Let's have him work on the data itself. No need to even know about the nodes. Okay, and I'll say node handler dot handle, passing in the data. And then we'll pass the node handler to the recursive calls, kind of like that, and I can get rid of this process method now. So now this guy's nice and generic. He has fixed objects he's creating, so I don't need those overridden factory methods. I can just create the binary tree node 3s. And in my in-order traversal, I can pass in the what I want to do for each node that I'm at. Make sense? Questions so far? Okay, so let's go ahead and plug this guy in and see what we can do. And now you'll notice that in order is requiring me to pass something in. So I can pass in a lambda here, something like that. Now note I can also, because I have a single argument here and the same argument is being called on that method, I can use a method constant here, right? Let's run that. And we'll see that those last two ended up exactly the same there. Everything overall is turning out exactly the same. But now I'm very, very flexible. I can pass in the what to do. So I could do something completely different here. I don't have to print out the values. I could do something, let's say that we wanted to create a sum of the things that are inside, create a sum of the data. So what I could do, let's create a little, I'll just use an array for it. So I'll say int sum equals new int, I'll just get a 0 there. And then what I can do inside here is say, when I get my data coming in, I'm going to say sum sub 0 plus equals data.getAge. And then we can print that guy out. Kind of like that. We get 117. Make sense there? That's kind of nifty, huh? Now, why did I put it in an array? Any ideas? Ah. Notice something here? I'm using sum, and it's not final here, right? Remember that this lambda is going to create an anonymous inner class. And with an anonymous inner class, any variables you reference any external variables must be marked final or they must be member variables. The reason they're marked final is because we're not true closures. If they change, we don't want the user to get confused or the programmer to get confused. So they decided you just plain can't change them. You have to make them final. So what this means is that sum has to be final. But because I didn't put final in it and it's being used in a lambda, it's now considered effectively final. They basically automatically add that final to you. Now, if I were to come in here and say sum equals something else, like that, I'll say, actually, I think that's going to be the error, right? Oh, only initializers. If I did something like that, notice here it gives me an error. Local variable sum defined in a closing scope must be final or effectively final. So it's checking to see, oh, hey, wait a minute, you're changing at some other point. That's not allowed. So what this lets you do is as long as you don't actually change it, you don't have to explicitly mark it final, but it's still treated as final. Make sense? Now, if sum is final, why can I change sum sub 0? I just can't change the reference itself. Sum is a pointer to an array. So if we have, here's my array over here with the data in it, sum is just pointing to that array. So I can't make it point to another array, but I can follow him and change the contents if I want to. Make sense? Okay, so I just used the little array as a simple way to have something I can follow and change, because I knew up front it had to be final. Okay, I could have just as easily created a class that just holds a single integer and then used a pointer to that and update that single integer there. Okay, so far so good. So we've now defined something that we can use a new lambda. All we need to do is define a new interface. But there is a gotcha. The gotcha is that your interface can only have a single abstract method in it. And that single abstract method is handle. If I had multiple methods in here, void foo, for example, we come back over to trees, and he's going to say here, the target of this expression must be a functional interface. And by functional interface, they mean an interface that has a single abstract method, or capital S, capital A, capital M. Well, in an interface, you can only have abstract methods, right? That makes sense, doesn't it? So why would we call out single abstract method? Well, it turns out they added something new in Java 8 called default methods. You can actually create a new method in this interface that actually has a body. And that's really useful for something we're going to see when we talk about streams in a moment. When you have a stream, you can do something like, let me go over to, where's my sorting one? You can do something like this, people.stream, and then do something with it after that. And we're going to see that in a minute. Well, take a look at this. What type is people? What is people there? It's a list. And what is list? It's an interface. Well, I'm calling stream on an interface there. Now that should be okay because somebody has to implement it, right? So that would mean that array list has to implement stream, right? Sounds reasonable. Until you start thinking about, the other day I was programming in Java 7 and I created an implementation of list. What's going to happen in Java 8 if they add that new stream method to the list interface? Compiler error, my code's going to blow up, right? Because stream is not defined in my list. They've now broken me by adding something to the API. To get around that, and they really, really wanted to do this, they wanted to say any collection, you can just say .stream and start a stream from it. To get around this, they created this new thing called default methods. And so you can define this default method, and let's just take a quick look at what he looks like. Notice the word default there? This is in the interface for list, actually the interface for collection. It's higher up than that. And look, there's a body. So what this does is it copies that code down into your implementation. It gives you a default implementation of that. Kind of freaky, huh? Now, you obviously can't have any instance variables, but you can refer to other methods that might be overridden in the subclasses or the implementations. Make sense? So it's a really cool little construct there, but now you might have what's called the diamond issue, the diamond problem. Let's say you have two interfaces that both define stream, and you want to implement both those interfaces. Now, and let's say that they're both default methods there. Now you've got to say in your class which one you care about, and you have to actually reference you basically have to override it and call the right one prefixed with the interface name. It's pretty gross. It's kind of like when you're inside an anonymous inner class and you have to say foo.this to refer to the outer this. You have to do something similar with the interface name to refer to which of those two methods you want. It's pretty gross. And I fully expect that this is going to cause lots and lots of problems after a couple of releases of Java down the road. The problem's going to happen that if your average user starts taking advantage of this, saying, hey, wow, I can create mix-ins, right? I can have all these interfaces that have all these default methods and just treat them as multiple inheritance, right? I could do that. That's kind of neat. Well, a lot of users are going to start doing that, and I'm really scared about that because all it takes is adding one method to one interface, and kaboom, you blow up. This, to me, is very similar to that, which is called import on demand. Import on demand is pure, unadulterated evil. It was one of these functions, one of these features that they put into the language right up front because it was convenient. And the problem is they didn't think about things. They didn't think about what happened if in Java 1 you did that and then said something like that. So maybe in Java 1 you were thinking AWT list, right? And you were also using a vector, which was in util. So that code there with list would compile perfectly fine in Java 1, but as soon as they added list to util in Java 1.2, your code stops compiling. And there's no reason on earth that your code should stop compiling because somebody added a method to a library. So, and that's what this thing does. So don't use import on demand, ever. Ever. Come on. Why is it staying there? It's supposed to fix that for me. There we go. Let's do Control-Shift-O. Okay, questions on that? So my advice, do not create your own default methods. Let them use it in the Java SDK because they have full control of that, right? But if you start using your own default methods and start mixing and matching different interfaces, you're going to run into some trouble down the line. Okay. Yes? Well, because in the case of this particular one, they needed to actually get to member data. And so the only way they could do that was call other member methods. And to do that, it had to be a member method. So it's a little unfortunate, but that's the way it ended up working. There is no resolution order. You have to be explicit. So what you have to do is override it explicitly and then call the super version. So you'd say interface, I believe it's interface.super. The method name. I'd have to look it up to be sure because I haven't tried it yet. But it's something very similar to that. Okay, let's see. So keep in mind when you're defining your interface here, you have one single abstract method on there. Now, they've defined several interfaces that are very helpful to start with. This interface here, we're basically saying, take something and do something with it. Don't return anything. I'm consuming the data. I'm not producing anything. I'm not modifying anything. I'm just consuming it, end of story. Now they have an interface called consumer that does that for us. So instead of defining node handler here, I could actually take advantage of a method of the interface that already exists. So if I take binary tree node and make a binary tree node 4, I can come into him, and instead of taking a node handler, I can have a consumer, and I say consumer.accept, or node handler.accept in this case. Let me rename node handler to consumer here. Okay, so now I no longer need to define my own interface there. And I can take advantage of the lambdas the same way. So I go to my trees over here. And let's copy this guy. And we'll say this is binary tree node 4. And note that I didn't need to change the actual code in my Lambda. All it cares is that there's a single method taking that object type. And so now this should work just fine. And we say poof. Very nice, huh? Okay, now there's a bunch of other ones. There are predicate, and he is going to take some value and return a Boolean. Now what might that be useful for? Filtering. It's great for filtering. So if you have a filter method, you can pass in a predicate, which will look at the piece of data and return true or false, and then you can decide, do I want to include the data or not? We have binary operator, and he's going to take two values and return, let me say x and y, and return a third value. So you can use that for adding things, you can use it for concatenating things, stuff like that. We have unary operator, which takes in an x and gives you a y. We have function. I should say actually it's something of type x that returns the same type. You have function, which is taking in an x and returning something of a different type. Consumer we saw. And then you have one called supplier, which takes no arguments and produces something. That can be useful if you want to have it generate random items or something, or generate new things, maybe for a factory. It's very useful for factory methods. Okay, so you can use these as common interfaces, and they cover a lot of ground for you. Because when you think about it, when you're creating that Lambda definition, you really don't care about the name of that interface, right? All you care is something's going in, something's coming out. What's going in and out? Is it the same thing? Is nothing coming out? Is nothing coming in? Do I have two things coming in? That's really what you care about, right? So you can use these very, very effectively and not have to write a whole bunch of extra interfaces all over the place. Okay, so let's see. I did those, did that. And let's suppose that we wanted to pass something in to let it decide what when the consumer should be called. We'll just pass a predicate in for that. Where's the definition of consumer? So if we take a look in binary tree node 4, I'm just going to control click on him, and he's in the JDK itself. And all he does is have that one accept method there. Now, he also has this little and then guy, which I'm going to mention in a minute here, but that allows you to kind of concatenate operations, chain operations together. So let's set this guy up so I not only pass in a consumer, but I'm going to pass in a predicate. And I'm going to say if predicate test data, then accept the data. So now I'll only pass it to the consumer if the predicate holds true. Come back over to my trees. Ooh, where'd I go? And now I need two things down here. So I'm going to have data coming in for my predicate. And let's say that I want to only operate on people who are under 40. So I'll say data.getAge is less than 40. So I'm only going to print out people who are less than 40 there. Let's run that. And there we go. We just get the two people who are less than 40. Okay, kind of nice, huh? Now let's say I wanted to reuse that predicate more than just the one place here. Let's call this less than 40. And what I'm defining here is something that implements the predicate interface. I'm going to call it less than 40. And here's the definition of that object that I'm creating. So the object that is creating is going to implement that anonymous inner class for predicate based on the information over here. So what it does is it creates that predicate. It says the parameter coming in is going to be of type person, and here's the body of that method. Make sense? And now I can just pass in order, less than 40. And let's run that, just make sure he still works. Looks good. And let's add another condition. Let's say that I want to also test for starts with C. So say data get name starts with C. So I could say here less than 40 dot and starts with C. And so what it'll do is it will short circuit those operations for us. If less than 40 is false, it won't bother running the starts with C. So it's just like the and operation, operator in Java. So if I run that, and there we go. So now we just get the one person coming out of that at that point. If I had one other person who starts with C, Cameron. Let's put him as 18. So he's going to pass the less than, actually let's make him greater than. So we'll just make sure that we still only see Claire there. Oops. So Cameron is 38. Oh, less than 40. Duh. Let's make him 58. For some reason I thought I put less than 20 there. There we go. So it's still not seeing Cameron because that first condition still held true. So you can chain operators together. You have an and, or you also have a negate. So if I wanted to say people who are not less than 40, I could do that and start with C. And that should give me Cameron, just like that. And you can have an or as well in there. Now you can also chain together functions. So you can take a function and say and then, like we saw in that other one. So you're going to run the one function, take the result, and pass it into the next function. You can also use an operator called, actually, it's a composer and then. I can't remember the difference between, there's two of them, compose and then, and I can't remember. Oh, it's actually, the order's reversed. They're kind of stupid. So if we had a function, and let's do a G. I could say f dot and then G to compose them. So it'll run f, take the result, and put it through G. Or I could do the reverse. I could say G compose f. And they both do exactly the same thing. I don't know why they decided to go that way. I guess in functional programming, there's an idea of composition and an and then type operator, and they wanted to cover both. I'm not that familiar with it, so I don't know for sure. It just seems to me that that's potential for confusion there, that people are going to get things in the wrong order there. Okay, and with a consumer, if you have a consumer, you can say chain. So you have your first consumer dot chain, a second consumer. It passes the argument to the first guy, then it passes the same argument to the second guy. So everybody in that consumer chain gets to handle it. Okay. So he basically performs a not. So it says, do less than 40, flip the result, doing a not. It's kind of the same as saying not less than 40, if you could say it that way. So it just reverses the result. Okay, questions on anything there that I've covered? So those are that's basically what I want to talk about for lambdas. And they're pretty useful. They give you a lot nicer way of representing things in anonymous inner classes. And I really wish they had done this early on, because every time I've taught anonymous inner classes, I get people who just their heads want to explode because it's ugly. There'll be some people who just think it's ugly. There are other people who just have trouble wrapping their head around it, mainly because it's ugly. It's kind of hard to see what it's doing. With a lambda, it's a little bit more obvious what's going on there. You can look at something like that and say, here's my parameter, here's what to do with the parameter. Not too bad. Okay? Questions on any of that? Okay. No, go ahead. Yes, you were very late, Marcus. Yes, and that's gonna be the second part. We're talking about streams, so we're gonna take advantage of those there. Okay, why don't we go ahead and take a 5-minute break? Let everybody get up and stretch for a moment, and then I will start into streams. Okay, any other questions? Yes. Hmm? Well, yeah. So with the lambdas, you can only use interfaces that do have a single abstract method. If there were multiple methods, it just wouldn't let you use them. And that's the error where it's said that it must be a functional interface, and you just have a single method there. Now you're allowed to have default methods if you want, so you could have a default in there. Again, I would recommend don't write your own default methods, because I think we're gonna hit collisionville pretty quickly on that. But I know a lot of people are going to try to say, "Hey, multiple inheritance," and pull things in. Mhm. Mhm. So the question is, what if when I write an interface and I put it in a library and it has a single method and people start using it passing lambdas in, and then I, as the library writer, add another method there? I'm going to start getting death threats and things like that. There's a little bit of a solution to that. And one of the things you can do is when you're defining that interface, like if I define this new node handler here, I can say implement extends. I have an interface here. Functional, or actually, I'm sorry, I'm doing that wrong. I just annotate it. So one thing you can do is if you throw the word functional interface on something, that's your way of telling people, I intend this to be able to be used as a functional interface. So I intend it to be a single abstract method interface. And I believe, yeah, it'll give me an error now. The compiler will say, hey, it's not a functional interface, you lied to me. So that's something you can do to mark it to say, I intend it to be used that way. And that's my note to myself to stop me from accidentally doing that. However, if I don't do that, there's nothing stopping me. Now, you could say, if I publish an interface and don't say this, I'm not making a guarantee to anybody that they can use it as a functional interface. And so that's kind of the way that I would view it, is that if it's not documented as safe to do that, as a developer, I'm free to add to it. However, if I'm publishing this as an interface I expect other people to implement, I should never ever be adding methods to it. because that'll break anybody, regardless if they're doing a Lambda or if they're doing an anonymous inner class or a full up class implementation. Because now yeah, you're going to get the death threats. So typically what you want to do is if you want to add another method, you want to create an extension of the interface. And then you'd have your class implement the extension of the interface there. And if people were implementing the older interface, they're still going to be okay. That's usually what you want to do. But then in your code, you have to do a little test to say, is it actually an implementation of the sub interface before you try using any of those methods? So it's a little bit harder. Yeah, writing a library is really a tough thing. You know, you've got to be very, very careful. Excuse me. One of the things you can do in Eclipse in particular, they have a set of tools called the API tools. And what the API tools let you do is you can take a version of your library, run the API tools against it, and then run the API tools against a later version, and it'll tell you where there's potential breakage. So it'll catch things like you added a parameter to a method in an interface, you added a new method to an interface, you removed something from a, there's certain removals that'll cause problems there. And that's a really useful tool to help you just double check, hey, my library is still going to be safe. And then if you are going to make breaking changes, increment that major version number. So, major version number, increment that major version number to say, I intend that this is a breaking change. Something like that. Make sense? Okay, any other questions? Oh, yes? So the question is, if Java wanted to have a functional interface, why didn't they have a type that you could, So instead of an interface, do something more, so create a brand new type of structure, you mean? So kind of like when they added annotations. The main thing that they wanted to do is they wanted to still be compatible with all the old single abstract method interfaces. So any old functional interfaces, they wanted to allow you to now use lambdas to call those, but not break anybody who's using anonymous inner classes or full up classes. So they really were trying to, and I think they ended up doing a pretty good job with this. There's a couple little holes here and there, but overall they did, I think, a really good job of coming up with something that is useful, more concise, and still gives you a lot of backward compatibility. And then suddenly you now get to be able to use lambdas in a lot of places that you didn't have to explicitly code for. So if they had done something with a new data structure type, or that's not the right word for it, but if they'd done something with a new type of type, then it wouldn't work with any old code. It would have to kind of wait until people start using this feature. And I don't think it would have picked up any traction. It would have picked up traction with people who are really into functional programming and people who like the way that lambdas look, but a lot of the people wouldn't have done it. Okay. Other questions? Mm-hmm. Oh. So the question is, you've been coding using anonymous inner classes or inner classes for so long, why would you jump into this? And the answer there is when you're writing new code, if you write it this way, it's going to be much easier for somebody to look at and understand than that. Now, you don't have to. It's completely up to you, whatever you feel comfortable with. But I think once you start feeling comfortable with this, as long as you're using Java 8, I'd say go ahead and just start trying to do these once in a while. And I think it's just going to feel more natural after a little bit. And it's a lot less typing. I mean, even though the IDE creates the anonymous inner class for me, so it's really not that big a deal, looking at this, I find it just infinitely more readable than this, especially whenever I type one of these in front of students. They look at it and they start scratching their head. And they're like, what did you just do? And creating that is a lot more work than it looks like it should be. So, but again, you don't have to use it. I'd recommend trying it, just kind of see how it feels. I think it'll grow on you pretty quickly. Unfortunately for me, most of my programming is Android programming, and they don't support Java 8. So I can't use lambdas in there. I'd love to, but I can't. Okay, so other questions? Okay, onward we go. So let's talk about streams. Now, let's think about collections for a minute. When you create a collection, your collection like a list is going to look kind of like that, right? You have, here's your list, and here's your data. And the list has a little array inside it, or a linked list, depending on how it's implemented, pointing to all of your data. When you create a list, you have all the data in that list. Everything is there right from the start, whether you need it or not. So if you wanted to say, let me scan through and find everything that find the 20th person, let me scan through and find the first person whose name is Clyde, you have to get all the data that you might potentially want to look at. Make sense so far? Now with a stream, streams are on-demand structures. What you're doing is you're creating a source that's going to provide data for you. Now that source could be a collection, or it could be another type of source that creates elements on the fly, or fetches items out of a database on the fly, or does something else on the fly. The source is then going to pass one element at a time to the operations you want to perform. Each of these operations is going to do some kind of a modification on that data and pass it on to the next guy. Now, if one of these operations in the middle decides that he wants to filter things out, like let's say it's a filter operation, he gets that single item, he just doesn't pass it to the next guy in the chain. Now what's really nice about this is if you think about a list here, and let's say we want to filter a list, how would you think about filtering a list? Maybe you want to remove everybody named Scott. How might you do that using a list? So you either have to modify it or copy it. So you'd either modify in place and actually remove things, which is good if you really want that to be the long-term goal, right? But if I just wanted to do it for this one operation, I'd have to create another list over here and then copy the items that I care about and omit the ones that I don't care about, right? So now I've got an entire new copy of things here. With streams, you don't do that. If you filter, you're passing things through this chain of operations, and you say, oh, I don't care about it, don't pass it to the next guy. So it's basically a chain of responsibility, if you've heard of that in the Gang of Four design patterns. And you're going to pass to something, you may pass it to the next guy in the chain or not. You may modify it and pass it to the next guy in the chain. Make sense so far? In a stream, you have a couple types of operations. You have a terminal operation, and this is where you return the final result. So you're done doing any stream processing. So you've got an element and you return some result out of it. And then we have intermediate operations, which just continue passing data down through the stream after some potential modification of that data. Okay, so there's no intermediate data structure created for these things. When you filter things out, you're not creating another list. You're just not passing things to these operations. That's the way you want to think about these guys. Okay, now you can think about all these operations as being lazy. You don't compute data up front. You compute data when it's pulled. So if you think of this chain of operations here, we go to the end, and he wants to try to pull an element. So he goes to the previous guy and says, "Give me your next element." He goes to the previous guy and says, "Give me your next element," and it kind of percolates forward to get an element, sucking it down. So you only ever pull data when you need it, and this means if you have like an operation on the end, like find first, with a predicate in it that says, I want to find the first thing that matches it, you're pulling a guy, testing him, pulling a guy, testing him, pulling a guy, testing him. So you only go as far as you need through the list. If this guy up here is generating stuff, you're only going to generate the number of elements that you actually need to start with. Make sense? Now think about this if you wanted to compute Fibonacci numbers. You could have a source here that generates the next number in the sequence, and then have elements down the pipe here that might say, I want to limit the number of results to 20. Somebody down here might say, I want to grab the next element and do something, do something, do something, do something, but you're only going to generate as many as you need. You can have a potentially, I'm going to put in quotes, infinite sequence of things that you operate on. And in the case of Fibonacci sequence is a good example there because it's an infinite sequence. We could just generate on and on and on forever, right? Make sense? Okay. And what's nice about with streams here is you don't have to create a big old list with all your numbers in it to process it. You just create a number, pass it through, create a number, pass it through, create a number, pass it through. Okay. So let's see how we create some streams. I'm going to take that list that I created earlier. Start with that, so we just have some people in there. And I can say people.stream. And that's going to create a stream to start with. And then I can now pass through other operations. For example, for each. This is going to say, for each item, I'm going to perform some action against it. So here's a consumer here. It's a consumer. I can now use a lambda there. I could do something like system.out, println. And if I run this guy, boom, I get the people printed out. Pretty nice. That worked out nicely for me. What if I want to limit it to the first two items? I could do something like that, and then boom, I only get two items going through. And what that's going to do is the for each is going to ask the limit, give me the next item, and the limit's going to say, I'm done. I'm not giving you any more. And so he's not going to ask the stream for any more people to send through. Make sense so far? Now, if you just have some loose objects standing around, you don't have to create a list to start with. Let's say that I create Scott. I create Steve. Create Claire. Create Kai. So I've created all those people. I can actually just create a stream of those directly by saying stream of, and then put the list of them in here. Scott, Steve, and let's just say I said Claire. Oh, actually, I don't want to do that. And then perform actions on them after that. You know, for each p.get name. Maybe I just want to print the names. And we'll run that. And now we just get the names coming out of there. So you can assemble data that you have sitting around together, or you can take a collection that's existing, or you can generate new data on the fly. Now, let's see, what do I want to do here? I can just show you the generation real quick. If I say stream.generate, I can pass in a supplier here. Let's see, how do I want to do this? So this is going to generate a brand new person. Oh, I should put an age in there. They're all going to be 42. And oops, what does he not like there? And then we'll just say, let's limit it to 20 people. And then we'll just print them out. And we'll run that. And now we see that we just generated 20 people there. And it only did this new person as many times as we needed it to do. So that's just one example of how we might do a generation or something like that. You could have this maybe go off to a database and fetch the next row, fetch the next row, fetch the next row, fetch the next row. So maybe you grabbed a cursor earlier on and you're creating a person based on the current position of that cursor in your database. Okay. Now, as far as intermediate operations go, we can start applying some filtering, which is where this gets interesting. So if I took this people up here, I can say filter and pass into it, here's my person, p.getAge is less than 40. So I could do that same kind of thing I did before, but now I'm just filtering it out along the way. And then I'm going to print them out. So if I did that, let's put a little marker in here. Let me actually comment that one out because he's going to make it noisy. So we'll see that I just printed out the two people who are under 20 now, or under 40 now. Questions on that? Filters are a really useful little operation there. Now, I can also use that in a conditional. Let's say that what I care about is checking to see if something's found. So I can say if people.stream, any match, pass a predicate in. And now I can print out someone is less than 40. And we get that coming out as our answer. There's also a none match, and what was the other one there? All match. So if you want to make sure that everything in the list matches something or nothing in the list matches something, you have those options as well. Maybe we want to do something really simple. How many people are in that list? There's 4. Now, if you're using a static list up front, this is kind of a lame way to count what's in the list. You've already got your static list. You might as well just call size on it, right? Okay. But you can count if you've done a bunch of operations. Maybe you want to say how many people are less than 40. So you could filter it and then do the count, and then it actually becomes kind of useful. So 2 people are less than 40 there. Okay. Now we get more interesting when we start mapping the values to other values. So let's say what we want to do is we want to take the people and, well, you know what actually would be, do I want to do the other example first? Yeah, let's do that other example. Let's do doing good on time. Where's my person? Let's create another person here. And this one, I'm going to add a father in here. So I'm going to say private person2 father. Add in my getters and setters for him. Let's fix my constructor. And we'll do something kind of like that. Let's just change these to, I'll just leave those. I'll create a new one. Okay, so let's say I don't have a father. Steve doesn't have a father. Well, let's go ahead and create a person. Let's create a father there. Why not? And this should be person 2's. Well, you know, I might as well make Steve his father. Okay, what is he not liking there? Oh, yes, thank you. And Scott too. Okay, so now I've got a father in there. Let's first of all walk through and see who has a father. So I'm going to say people2 dot stream filter p dot get father is not equal to null. And then once we filter it, let's go ahead and do a for each print out. Why is it not letting me print out there? Oh, might help if I did that. And then we can say p.getName is the child of p.getFather.getName. Something kind of like that. And we run that. Scott's the child of Oliver, Steve's the child of Oliver, Claire's the child of Scott, Kai's the child of Steve. So far, so good, right? Now, maybe what we want to do is just get the names of people who are fathers. So what we can do here is say people2.stream. And what I want to do is take each person and convert it into that person's father. So I have a list of people coming in, and the list coming out is going to be fathers. So I'm going to say map p to p.getFather. So what I should see coming in is Oliver, I'm going to get a null coming back. Scott's going to return Oliver, Steve's going to return Oliver, Claire's going to return Scott, Kai's going to return Steve. This is totally not going to go the way I want it to, because I'm going to get duplicates here. There's a way, distinct is what I want to do. So let's make them distinct. So that'll reduce the duplicates for us there. And so now I just have fathers, and I can print the fathers out. Now the problem is that there's going to be a null in there. We'll leave that out for the moment. Let's not worry about it. And let's see how that goes. So there's the null that I was talking about because Oliver doesn't have it. And then we get Oliver, Scott, and Steve are fathers. So now we got the list of fathers. If I hadn't done the distinct, I should see Oliver twice. Yeah, so I see Oliver twice in that one. So I really want a distinct on that one. Okay, so this is now giving me a way to take the data and return something else from it. Another example of this might be if I say I want to get the age of everyone and then add them up. So I could do something like for each, passing in, let me create my little int array here. But now what's coming in at this point is going to be the age. It's not going to be the person. And so I can say sum sub 0 plus equals age. That shouldn't be working. Oh, actually, that's fine. Okay, so this is going to return a list of integer objects and then sum them up. And then after that, I should be able to say print out sum sub 0. And there we go, 187. So we've added up all those ages and returned 187. Now there's an easier way to do that. Because things like this are pretty common when you're dealing with numbers, you can get max and min and average and age and things like that. They have this set up so that you can return not just a map, you can return a map of integers. And that's a special one that has some extra methods associated with it. So I can say sum. And then that will internally calculate that sum for me instead of having to have that extra variable floating around. And I can just print that directly. boom, and I get the same result there. And now if I wanted the average, I could do the same thing. I can also print out max and min. Okay, and I'll get to optionals in just a minute here. But we're seeing that the average is 37.4, 70 is the max, and 7 is the min. Okay, so far? Now let's think about this for a minute. What would happen for this little sum function here? Well, let me write it out a little bit differently before we say that. Let's say instead of using that sum, what I'm going to do is I'm going to create a map of ints, and I want to calculate that sum personally. I can use a reduce function here, and reduce takes a binary operator. What it'll do is it'll take in the accumulator value so far, and then the current value in the list, and return the accumulator. So it's a way of kind of adding up things over time. So I can say I comma j is I plus j. Actually, let me write it this way. Accumulator value, I'll call it item. Return accumulator plus item. And let's go ahead and run that. And we'll see that he came up with the 187 there. Now think about what this is doing for a minute here. When this is coming in, I'm going to try to call this function on each pair of items. What if there's no items in the list? I'm not going to have anything to add up, right? So I need some way of describing that there wasn't anything there. Now, in a lot of programs, people will use the value null to say there's no return value, nothing coming back, something's not found. Well, think about that for a minute. What if null had a valid meaning? What if null was your way of saying I didn't want to have something there, as opposed to it's just not found? Think about a hash map. If I say I have a map string, we'll say it's string to string. And let's say that I put in there nicknames for people. I'll call it nicknames. Well, you know, Claire is just too cool to have a nickname, so I'm not gonna give her a nickname. But I'm explicitly saying she doesn't have a nickname, right? Note that I'm not putting Kai in this list. I'm saying that I haven't defined Kai's nickname, but I have defined Claire's nickname and there isn't one. Now null has a double purpose here. If I come in here and I say nicknames get Claire, and I do the same thing for Kai, what values am I going to get for those? I'm going to get nulls for both of those, right? I'm missing the concept of the nickname is explicitly not defined versus I didn't decide what the nickname is. Does that make sense? Now this is a bit of a problem. That null's ambiguous. And this actually comes up in quite a few places, especially like when you're using something like a map, because sometimes you just didn't consider something versus you're explicitly saying, no, it doesn't have one. And that's a little tricky. So what we can do is come up with another concept to describe, no, it's not there. You know, I explicitly thought about it, but it's not there. And so what we can do is we can define this thing called an optional. Well, optional string, I'll say. And this is a value that you can use to explicitly say, yes, I considered it, but it's not there. And so I can say optional string Claire nickname optional. Optional empty, something like that. Whoops. And so what this means is this value, I can ask it, is there a value there or not? If I define my array of nicknames a little differently, now when I get this, I can actually ask some questions here. I can say if Claire nickname is present, then I can do something with it. Get the value from it, kind of like that. And in this particular example, I can say if Kai nickname is null, print out not found. So I now have a third option there, right? I have an option of considered, but I'm defining it explicitly no, versus I never considered it. So this is one way I can do something like that. Now, if I had a special map, I could have the map always store optionals. And when I get a value back, instead of having a potential null pointer exception, I can just talk to the optional. So I could say something like Claire nickname dot if present perform a consumer. So it's just out println. Something like that. And this will only print her name if it's present. So let's do something kind of like for map.entry string, oops, optional string. And this is nicknames entry set. And now inside here, I can say entry dot value, get value, if present, print it. So I will only print the nicknames that are present. So I get Java Dude and Thunderbean. Okay, make sense? Yes. Mm-hmm. This is actually not a great use of optional in this case, but that was just trying to show that now I have a third option to say that it's just not, it wasn't actually put into the list to start with. In this one, it would be, because with unfortunately maps don't have native optional support built into them, and they didn't want to change the interface on it. So when you say get Kai, it's still going to return a null, but not a great way to use optional. Typically, you'd want to use optional to say it's there or it's not there. Mm-hmm. No, you're going to walk the stream multiple times there. Now, what you could do is there's what's the name of the thing? It's like statistics or something. Summary statistics. So if you use summary statistics, it returns you an object that has all those things calculated for you. So it's only actually visited them once. So if you only need to do one thing, let me show you what that would look like. So then I could say summary statistics, get max, get min, get sum, get average, things like that, and get count, how many things there were. And what this does is this gives you all 4 of those things just with one cycle through. Now, if you had multiple operations you wanted to perform, that's when you might want to use the and then. So you could have the, let's see, where's an example I could do that with? So here where I say this stuff, let's see, how would I write that in here? So you could have a different consumer after there. I'll just say print it again, why not? So you could have multiple consumers chained together and do something kind of like that. And so now you're only, oops, what is he not liking there? It's going to be the type on those. The types are not matching. I think if I just do this, it'll take care of it. Yeah, there we go. So print it and then do another consumer. So you could chain multiple consumers. So if you had multiple separate operations you wanted to perform, you could do them, and then that way you don't have to traverse the thing multiple times. But yeah, in these ones here, you're definitely going to be traversing it multiple times. Oh yeah, I'll get there. Yeah, you can produce a list as well. I will get there. Mm-hmm. One more time. Mm-hmm. Okay, so the question was, with the reduce, each item in turn is passed to that accumulator, this function here that's being passed in. It's a binary operator. And what happens is this binary operator that they defined here for reduce, he's keeping track of, when you define that reduce step, he keeps track of what's called an accumulator. And that's kind of like your summed value. And so what that value will get assigned to the result of your binary operator each time. So for each element, we keep track of what the accumulated value is. And then the next time we call it, we pass in the current accumulation, so basically the current sum in this particular example, and then pass in the next item that we want to have. So one place where this is actually, let's do something slightly different here. If I take the people, I'm going to just grab their names. So I'm using a method constant here. Whoops, person 2, I guess. And then my reduction here, instead of producing a sum, I'm going to produce a concatenated comma-separated list here. So my accumulation is going to be that string that's building up. And then I'm going to put commas in between, kind of like that. And what that should print out, let's just see if this is going to work. There we go. So we see that we have Oliver, comma Scott, comma Steve, comma Claire, comma Kai. So you can use something like that to form a comma-separated list. So the accumulator is just kind of like your working copy, the working data. And then you're modifying that working data, replacing it each time through the reducer. So that's the whole idea of the reducer. He just keeps track of the current result, and then you perform some operation to change the current result each time. Okay, so let's see. I was down here with, I got the nicknames coming out there. So you'll notice that in this one, he returned an optional as well. Each step along the way, you can perform an if present to say what you want to do with it, or you can have some other ways of handling this. So you can say, or else, return some value. It's not father's, no nickname. And we can just run that. And so now we see Steve is Thunderbean, Scott is Java dude. Claire has no nickname. And so we've now had that logic of what happens based on the optional, returning a default value instead. You also have the option of saying if there isn't a value, throw an exception. So you say or else throw. And what he takes is a supplier. So you're going to have no arguments. And you're going to say new, whatever your exception is. Did I miss a paren? Is that what it is? I think. There we go. And that should gag really quickly there. And then we get our exception on that. So you have an option to do that as well. I'm going to comment him out so he doesn't kill the rest of the example there. Okay so far? So now with this optional chain, you can let's see, make a copy of that guy. I can say entry get value. I can map it to something else. And that will pass in, it'll return some value. So I would have, this only happens if it has a value. It gets mapped. So I could say P, well, what's coming in? It's the nickname, it's a string. So string coming in, string plus foo. I should have just left that on there. Actually, I don't want to do it that way because then it'll print out garbage there. So we're going to have, it would say optional empty. So once I have that map, then I can say if present, print it out. Something like that. So this is a way of basically saying if I have the value, go ahead and do it without having to have that extra if null check, if not null check in there. So now I have Java dude foo and Thunderbean foo were printed out by that guy. Okay. Did I want to say anything else about that? Nope. Any other questions on that one? Yes. Can you do a null check in the stream? If there's an optional, you wouldn't do a null check. You'd do an if present. So you could either say if present run a consumer like this, or what you could do is say get the value and filter. Well, actually, I could do this up front. I could say filter optional is present. And then this would only pass through, whoops. Oh, it would be, I need the instance variable. Actually, no, that should have worked. Oh, I'm missing. Oh, did I have a semicolon in there? Maybe I do again. Really? Why is that not working there? Because the get value is an optional. That should have worked. I got to look at that one and see why that's not working, but that one should have worked. Because this way you can filter it out based on what's there or not. Why didn't that one work? Get value should be returning the optional, not the string. It's actually not a stream, but the filter should be allowing us to pick out that one. Mm-hmm. I thought this one would be. Oh, the filter I'm thinking of is if you have a stream of optionals, you could filter out that way. At this level, yeah, I thought you could do that, but no, it's actually passing the data in, but it'll only call that filter if the optional value is actually there. But I thought you could put that in there. So you have to use the if present with the consumer in order to make that one work. I'm trying to think if there's another way I could do that. Do the filtering earlier. Well, if we had a list of things, then we could just walk through them. So I think if I used the values up front, so I said nicknames.values filter, or nicknames.values.stream.filter. And then I could say optional is present, and then do something else with it. For each system dot out ::println. So this would be the way that you'd do it if you had a list of optionals. You can just filter through them and then print them out. And so this is like walking through the list and filtering out just the things that you know are actually there. Just make sure that comes up. So it's coming out as the optional. So what we're going to need to do now, this is pleasant. This is actually one of the places where they have a little hole in the API. They make this a little bit tougher to do if you have a list of optionals. So I have to say optional get. Oh, map. Now let's try running that. There we go. So that returns the actual value from there. So not terribly pretty when you have a list of optionals. But if you have a single optional, you can use the if present and you omit the if checks on those. The main point of the optional, though, is for you to have a way of distinguishing it's not really there and explicitly saying that rather than relying on null to try to mean that, because null can be ambiguous in some places. Okay, questions on the optional? And personally, I haven't found a huge amount of use for it yet. I mean, I've just started playing around with it, but it's one of those things that feels a little bit of funky to me. And I think once my mind wraps around it, I may have better luck with it. When you've done what? Right, so another option is to put in an actual dummy value. So you could have a dummy constant there. This is a little bit safer than that, though, because then even if somebody accidentally, if that dummy string actually ends up meaning something useful someday, I mean, I've done things with dummy strings like have, star star bang bang, some, foo bang bang star star, which is highly unlikely that somebody's going to enter, but there's always one person eventually that they will do something like that. Okay, so if you want to sort things, you can do something very similar. Where's my people up here? So I can say stream sorted. And you can either say sorted and rely on the comparator or rely on the natural comparable property, or you can pass in a comparator here to change that. Something like that. Okay. And let's take a look at a couple other ones here. Already talked about the any and all match type things and none match. Count, reduce, find first summary statistics. Yeah, I covered all those guys. I did the reduction stuff. Okay, so now let's talk just a little bit about when people talk about functional programming, which I'm not an expert in, and I am not a huge fan from what I know of it so far, mainly because of the way people abuse it. But one of the things that's nice about functional programming, if you think of everything in your program as being a function where you get some data in and you push some data out, and you're not modifying data in place. So if you had a function that has string 1 and string 2 coming in and returns string 3 is a new string that has a copy of the values of string 1 and string 2 in it, if you're concatenating, things like that. If you were saying pass in a person and I want to set his name, you're going to pass out a new person that has that different name. If you approach functional programming that way, one of the things that's kind of a nice side effect of this is that because this operation is piece of data, new piece of data, and you're not modifying any state, this operation could be done in parallel with other operations without any danger. So if I had two persons coming in, maybe it's the same person object coming in, this is setting the name, this is setting the address, and then maybe there's a third operation where I set some other field. These could all be run at the same time, and then the results merged later on. And it wouldn't hurt anything. So if you were creating a pipeline of these guys, obviously if they're passing from one into the next, it got to be run in order. Actually, they don't have to be run in order. They could be reordered because they're all just functions. What's the thing I was thinking of doing? Think about if you have a sum operation going on, where you're going to say, take x and y and z, and we're going to be adding them together. You could add those together and then add the result over here. Maybe I had a and b that I was going to add in. Because these guys are all commutative, you can mix and match them in any order and then take the results and sum them up later on. Does that make sense? So the order doesn't really matter for a lot of operations like this. If you're not modifying the actual data in place, you can do them in any order. You could do them at the same time, do some subtrees of this operation at the same time. And what that allows you to do is take advantage of more cores on your computer. One of the problems we have with computers now is we had Moore's Law working for us for a while, where computer speed was being able to be doubled every year and a half, something like that. Am I right on that? It was a year and a half for Moore's Law, I think it was. But basically the speed doubled every year and a half. We've pretty much hit a threshold on that, a plateau on that. And now instead of trying to increase the processor speeds, they're basically throwing more processors in. So now we have these machines like this guy here has got either 4 or 8 processors, I can't remember how many. Unless I'm running things in parallel, I'm not taking advantage of those extra processors. So if we can think more in breaking our program up into parallelizable pieces, the computer can then be responsible for throwing those pieces on different processors and actually work them at the same time. Now, just to kind of see a little quick example of how this might affect you and how dangerous it can be. Let's create a little helper method here. And we'll surround him. So here's this little helper method that's going to sleep for 500 milliseconds. I'm going to do this so that in my functions that I'm going to parallelize, I'm going to have it just sleep for a little bit, just to represent some unit of work that takes a little time to process. Now, if we were having this operation take some time on every one of our guys in our list here, so if I said people2.stream.forEach, I've got my person. Oh, what do I want to do? Actually, let's just do a summing on this. So I'm going to map it. So I'll say map p. We'll sleep for a moment. So we'll pretend that it actually is taking a little while to do the processing. And then we'll return p get age. Oh, I'm in a static there. That's in my main. Target type of this expression must be a functional interface. Oh, thank you. Wow. You know how long it's been since I've drawn an arrow to do a member reference? And for some reason I'm doing that and just staring at it like it's okay. That's weird. Okay, so let's say we're going to do something like this. I'll say map to int. and then I will do an average on him. So let's say that the average was really hard to compute. Let's just make sure that that actually prints up something that looks reasonable. There we go. Now notice how that took a little time to come up with. And it's returning that optional because we don't know if there's any items in the list. There might not have been. Actually, so what I should have done really is a if present system out println. So what I'm going to do is let's put a little timing in here just so we can capture how long that thing took. So say long start equals system current time millis end, and we'll say end minus start. Let's put a little thing on there. So this is sequential. And now what I'm going to do is do the exact same thing, except instead of say stream there, I'm going to say parallel stream. And what that's going to do is it's going to let it take these functions here and shove them out on multiple threads and then collect the result at the end. And let's see how long he takes. That's quite a bit of difference there. So we're actually taking advantage of the multiple processors doing the work on this. In this case, the work is just them sleeping, which isn't terribly useful. But we're seeing that when it takes a little bit more time to go, the multiple processors are able to do these things. Now, the gotchas here. This is crazy easy to put the word parallel stream in there, right? I used to be a little annoyed at Java to start with because it was way too easy to create a thread. And random people just started creating random threads, not knowing how to deal with thread safety, which is really not easy to do. Thread safety is a tough thing. There's a lot of rules. Very similar to this, it's way too easy to throw parallel stream in there thinking, wow, I can speed up my program. Because, you know, somebody's going to hear something about it and say to somebody else, oh, you just throw parallel stream and your program gets faster. And somebody else is going to misunderstand that and just throw it in everywhere. And, oh, the mess you're going to get. The stuff that happens in the functions down line here has to be thread safe. And you cannot be updating state in place. You have to treat things functional for this to work properly. So it's very tricky to get this to really work properly. You have to be very careful on it, very intentional on it. When you're using streams, don't just randomly throw in a parallel stream. Make sure that the operations you're performing are thread safe and not touching any program state. It just returns new values. Does that make sense? And then something like this can actually be very useful. Now, if you're careful and design your program with thread safety and parallelism in mind, you can take advantage of some stuff like this. But in general, be very, very careful of this guy. Yes? Yeah, actually, the order is going to be non-deterministic. It just depends on which thing you did. So if let's see, where was that guy? It'd be interesting to see that come up. Why am I not seeing it? Oh, up more? Oh, there it is. Okay. It was up a little farther than I remembered. So we took this down here, and we changed this to parallel stream. Now, in this particular case, we're getting a value, we're adding to an accumulator. Those are all okay, but the accumulator that we're doing here, we're relying on its order to be important. Now, if we don't care about the order, if we just say, hey, it's unordered, doesn't matter, then the order it comes up, no big deal. So if it's a set, for example, doesn't really matter. But if we're relying on that order, this may return a different result each time. Let me comment out this timed section up here. Oliver Scott, Steve, Claire, Kai. I think we're just getting lucky here. Well, if we threw some sleep in there, that might help. I think what's happening is that this is kicking off a thread and it's finishing before the next thread gets kicked off. So if we had it, let's do it in this map here, see if this will do it for us. There I go again. And we'll say sleep. And then return p.getName. Let's see if that'll do it. Let me think about this for a second. That's a good idea. So let's say oops. Let's make him static, might help. So random dot next int under 500, let's say. I think it's actually keeping the order. So I think, what was it? I think you have to tell it that the order is, it doesn't have to be ordered. No, it's still keeping the order for some reason here. That might actually be applying to when it's doing the reduce. The reduce is waiting for all the threads to be done and then concatenating them. I suspect that's what's going on, although I thought the unordered would take care of that, because each of in between here it's generating these special what they call splitter raters. It's a really nasty word, the splitter rater, so that you can have an iterator that can split into multiple parts, and there's a flag on that saying if the order matters or not. And so somehow in here the order is being kept track of as mattering, it looks to me. Or we're getting really, really lucky. But I suspect that it's more the order is getting tracked of. So it's something I'm not really that used to. So I'm going to have to play around with it and see if I can figure out why that's actually happening. But we shouldn't be able to, if we're saying unordered there, I believe we shouldn't be able to depend on the order coming out of that. So I'll have to play around with that a little bit and take a look. I believe so. I think you can pass it in here. Not there. Where did I see that? I would have to look. So off the top of my head, I'm not sure. I think I've seen that though. So you can pick the executor and you have some control over exactly how it splits it up and how many threads are being used. I just can't remember where I've seen that. So I would definitely have to take a look at that. Let's see. So any other questions on parallel before I move on? I just got one more thing to talk about. Okay, so let's say that you've done all this filtering and you want to get it back into a collection. So what we can do there, if we say p=to stream filter, and let's say p.getAge is less than 40, we can then recollect things into some other kind of data structure. And you pass in something called a collector. This is a thing that's going to create a data structure and drop items inside that data structure. There's a bunch of common collectors that you can use, like collectors.toList. This returns a lambda for you. So if we take a look at his code, hello. We'll see that he's actually returning a new thing here that creates the collector. Oh, that's ugly. So he's doing an accumulator type thing. So he's creating a new array list. He's using the add function inside there to add items to the list. Whew. Yeah, this is where my head starts turning around. But basically, we're taking a list. Which one's left? Okay, I'm not even going to try to think through this right now. But we're basically taking two lists and combining them. And so this is going to create a new list for you. No, no, no. That's what I wanted. And then you have that list to do whatever you want with at that point. You can do the same type of thing to create a map. The map one is a little bit more interesting. And he needs two mappers, two functions being passed in to say what's the key and what's the value. So this one here, I might want to pass in person get name, and here person 2. And then here I might want to pass in person 2 get age. And there we go. And then I'm going to assign that to this map string to integer. So it's figured out that it needs to be a string to integer. So that's one way we could actually index people by their name and get the results being their age. Or what we could also do there is say I want to just index people by their name. And here I just say P arrow P. So P comes in, P goes out. So it's just an identity function. Now we can get that by saying functions dot identity. And if we take a look at function dot identity, he looks pretty similar there, right? We're just returning that identity function. So usually I prefer to just do the P arrow P there, just because it's a little bit shorter. Okay, now and then that one. So person by name. Now what's really interesting is if you do a grouping function on it. So if we tweak person slightly here, and we make a person 3. Maybe we add a sex field in this. So we'll say public enum sex male female, and then I can have private sex, generate my getters and setters, and then fix my constructor, and let's come back over to here. This down at the bottom. And let's make this be people 3. Oops. This is one of those ones where I just wish I just changed the definition of the original object. Okay, so they're 3, 3, 3, 3, 3. Okay, so now we got them. Let's add in the sex of the people on here. Pardon the unbalanced sexes here. Did I do something wrong? Oh, thank you. There's always one more thing to tweak. Wow. Okay, so now we've got those. Let's take these and say people3 dot stream dot collect. Actually, oh, it was in here, yeah. Collectors grouping by. And what this allows you to do is pass in a function that separates things out in different buckets. So it's going to create a hash map of lists. And whatever function, whatever value you return from this function is going to be the key in that hash map. So in this case, I'm going to say I'm going to sort by sex. So I can say person get sex. And so if I assign that there, I now have a map of objects where there's a map of lists of people separated by sex in the buckets in the hash table. Make sense? This is something that I could have used, I don't know how many times in various things I've done over the years. And it's just a very useful little function for organizing things. That takes a good chunk of code by hand. And so this is where you're starting to see some of the things in Streams that can be really nice. But the biggest thing for Streams that's really nice is the on-demand nature of it, where you can create data on the fly. You don't have to cycle through everything. You don't have to create these intermediate data structures to do your filtering. It does that for you. And so if you had a bunch of intermediate operations for different types of filters and different types of predicates and mappings, and then at the end collect it into a list, it's much more efficient than doing these intermediate operations of just dumping into list, filter, dumping into list, filter, and so on. Okay, does that make some sense? So that's how you convert things back into lists or collections there. Various types of collections there. Any questions on anything? Okay, well, that's all I wanted to cover today. But I do want to say with parallel streams, use caution. It's really tempting. And then also default methods, use caution. Try not to go there. Okay, I will be posting the video for this and we'll be announcing it on the CM Jug list. We're always looking for people to talk at these. So if there's anything you want to talk about, it doesn't have to be anything formal. You know, I don't use any slides here or anything like that. Just something that you know something about and you want to let other people know. You know, if you find something really interesting, come talk about it. I mean, you don't have to be an expert or anything. Just come up, you know, get a group of people together and chat. And it can be a lot of fun. So thanks for coming.